We will learn the step-by-step procedure from straight through jointing of cables and installation and testing switchgear. Let us learn the step-by-step procedure for performing installation and testing of switchgear. 1. Installation of electrical switchboards. As you may know, an electrical switchboard is a device used to direct electricity from a power source to other areas of usage. It is an assembly of one or more panels, each of which contains switches that allow electricity to be redirected. Each of the panels features a series of switches that allow the panel to control the flow of electricity to the connected devices. This controls the flow of electricity and ensures that it will not cause damage to the circuitry. An electrical switchboard enhances the safety of using electricity for the operation of various appliances, machinery, and other devices. Now let us learn about installation of electrical switchboards. For the installation of electrical switchboards, we need to ensure that the entire project installation followed the intent of the design for the low voltage system as per approved drawings and compliance. Follow local and international standards. Fabricate all the switchboards at the manufacturer's place. Examine all parts of the adjoining works into which applicable work is to be placed before beginning installation in any area. If there is any condition that will prevent the proper execution of the work, installation should not proceed until such conditions are corrected by the contractor. Fix all equipment independently of the wiring system. Use zinc electroplated bolts, nuts, washers, and screws. Mount switchboard at 1800 mm from finished floor level to the top of equipment or unless shown on drawing or schedules. Ensure that clearance in front of switchgear is not less than 1 meter or as indicated. Maintain 1 meter distance at the back and also from the walls if it is a freestanding type design and has openable doors at the back. Number the terminals, cables and parts to correspond with manufacturer's certified drawings. Cables should be identified with cable tags. Wires with wire numbers or ferrules and connection TBs should be identified by TB numbers. Terminate cables inside the enclosure to secure cables. For flush installation, switchboard's conductors should terminate behind the board in an adaptable box. For surface mounting, trunking should be fixed between the board and ceiling or floor level. If not, the conduit runs directly into trunking, which prevents the correct installation of the trunking lid. Adequate earth continuity should be made between the various components. Switchboard tests. The following electrical tests must be carried out to all switchboards, sub-switchboards, main distribution boards, and motor starter panels. Tests at manufacturer's workshop. Acceptance tests should be carried out on the completely assembled switchboards and motor starter panels. All the switchboards and motor starter panels should be visually inspected for technical execution and conformity with the latest issue of approved drawings and the latest issue of the relevant standards. Spot checks should be made to verify the following. 1. Dimensions of panel. 2. The degree of protection of enclosures. 3. The effectiveness and reliability of operating mechanisms and interlock systems. 4. The proper mounting of components. 5. The internal wiring and cabling system. 6. The correct wiring of main and auxiliary circuits. 7. The suitability of clamping, earthing and terminating arrangements. 8. The availability of the earthing system throughout the switchgear. 9. Verification of the clearances and creepage distances. 10. Verification of mechanical operations. 11. Dielectric tests. The test voltage should be as per manufacturer guideline for 1 minute. 12. Testing of the mechanical and electrical operation of several functional units on a random basis, including the control and protective devices. Site tests. After the installation at site, each switchboard and motor starter panels shall be field tested. A report recording each item of the tests should be prepared. Following visual inspection should be done. 1. The correctness of location and mounting. 2. Labeling, nameplates and markings. 3. Verification of nuts and bolts torque on the bus bar. 4. observation of incoming and outgoing cable bracing, and certify that it is as per the manufacturer's recommendations. 5. Safety shutters and partitions. As you are seeing, it is for human safety. 6. Functional units, operating mechanisms and interlock systems. 7. Mounting of components. 8. Internal wiring and cabling system. 9. Earthing and termination arrangement. Now we will see step-by-step process of cable straight through jointing. You are seeing technician removing XLPE insulation from both cable. From one end cable, they are removing insulation at around 160 mm in length, and from other end cable, they are removing around insulation at around 100 mm in length. Now they are removing galvanized iron armor from cable from one cable and 100 mm in length XLPE insulation from other cable. Now inner insulation also removed. For straight through joint, we are using jointing kit of company 3M. Now we will show you major material available with jointing kit set. Tin copper braid to protect conductive wiring from interference and handling large current and low voltage. Cleaning solvent pouches to clean the XLPE insulation surface. Worm clips to ensure good electrical connection. Galvanized iron wire mesh to cover the joint area and provide outer protection against mechanical abuse. Stress control mastic 350 mm provides stress relief of the electrical field in all MV cables joints and terminations for power cable applications. The stress control mastic with excellent stress controlling and self-sticking properties make it widely used in heat shrink and cold shrink technologies. Stress control mastic equilibrate the electrical field and reduce electrical stress. Stress control mastic provides resistant to water and humidity, filling voids and irregular shapes. GMW tubes used for environmental protection of low voltage cable termination and insulating the connectors for low voltage straight through joints or splice rated up to 3.3 kV. Sealing mastic 100 mm length, 35 mm width, 1.5 mm thickness. Conformable and durable mastic with excellent moisture and environmental seal used for sealing medium voltage cables and accessories and covering sharp edges. PVC insulation tape. Thermally compatible, which insulate electrical wires and other materials that conduct electricity. PVC heat shrink tube. It has many useful applications, including to provide electrical insulation to wires, connections, joints, terminals. Now we will see the tools used in jointing. 1. Hexa cutter. 2. LPG gas system. 3. Hydraulic crimping tool. Now PVC heat shrink tube entering into the cable. Now they are folding the armor. Now we are removing cable insulation as per the size of jointing socket. You can see we have removed both sides cable insulation and socket fixed into the black color wire. Now we are inserting GMW tube in each wire. Now we are putting socket into other face. Now we are inserting worm clips on both sides of cable. Now we will insert crimping socket onto conductor jointing socket. At the time of crimping, we have to ensure that same color code cables should connect with each other. Now you can see blue phase crimping completed and both the cables end connected properly with cable socket. Now same way we will connect other color wire and will do crimping. Now you can see all phase, that is red, yellow and blue, and neutral, that is black color conductor connected with each other. Now with the help of aluminium oxide abrasive, we are removing uneven part from crimped terminal. Now with the help of cleaning solvent, we are cleaning all the terminal properly. Now we are fixing sealing mastic of size 100 mm length, 35 mm width, 1.5 mm thickness on each face and neutral joint terminal. Now on all joint terminal with the help of heat, we are properly placing GMW heat shrink tube. Again fixing sealing mastic of size 100 mm length, 35 mm width, 1.5 mm thickness at tube end point. Now we are fixing tin copper braid with worm clip, which will tighten on both the sides armor end. Now wrapping the worm clip with PVC insulated tape. Now we are fixing stress control mastic 350mm at warm clip and laying galvanized iron wire mesh properly between warm clip points. Now fixing PVC insulated tape on wire mesh. Now before placing outer heat shrinkable tube, we are making measurement at end point of tube fixing sealing mastic of size 100mm length, 35mm width, 1.5mm thickness. Now fixing outer heat shrinkable tube and applying heat for proper fixing of it. By this way, straight through joint completed.